Hello and welcome to our secondary snacks. My name's Tara Stuttard. I'm a secondary specialist with White Rose Maths, and today I'm going to be looking at Year 8 Standard Form. So the students would have seen Standard Form briefly in Year 7, but that was mainly a higher step. So now we're going to address it with all students. It builds on really nicely from the indices work that they would have done last term. So if you are familiar with our schemes, you would know this is how we lay out our small steps. So the ones I'm going to be looking at today in particular are investigating negative powers of 10, which links really nicely into that higher step there at the bottom using negative indices. And I'm also going to briefly look at working with numbers between 0 and 1 in standard form. Okay. If you use our schemes, this will be familiar to you. For each of our small steps presented like this. So you have notes and guidance, key vocab, you have your exemplar questions and key questions. And I'm going to be going through these today and sort of talking through how I'd use them in the classroom. So I've just enlarged that exemplar question there for you to point out this key bit of learning. So 10 to the power of 0 is equal to 1. Now, it's really important that you spend some time on this, because if the students do not understand this, they're not going to be able to make the link between positive powers and negative powers. Okay, so if we make a start, I'm going to start by using prior knowledge, and I'm going to use the place value grid. This is something that the students will be familiar with, so we can build on their knowledge. So we know that 1000 is 10 to the power of 3. If we then divide by 10, we get to 100, which is 10 to the power of 2. If we divide by 10 again, we get to 10, which is 10 to the power of 1. And if we divide by 10 again, we get to 1. Now, this is a key learning point, which is 10 to the power of 0. So it's really nice for them to see that in a place value grid. As always, they can multiply back up that place value grid if they multiply by 10. So let's take a closer look at that exemplar question. So we're going to start with what the students already know. They know that 10 cubed is 1000, 10 squared is 100, 10 to the power of 1 is 10. Now, what I want them to do is think about the relationships, what's actually happening here. The questions I might ask are, what's happening to the power? What we want them to realise is that the power is reducing by 1 every time. But what's happening to the number each time we do this? So we want them to see that the number is being divided by 10 each time. So it's important that they spot that pattern. Now, if we think about it, we want to take the next step. What happens next? So we can reduce that 1 by subtracting 1, which gives me 10 to the power of 0. And if I divide 10 by 10, I'm going to get 1. So again, there's that all-important fact, 10 to the power of 0 is equal to 1. And that links to the key questions in the schemes. So you could be asking, is anything to the power of 0 1? Is 12 to the power of 0 1? Or 8 to the power of 0 1? So then questions can really be covered here. Now the students are in a position to move on, and we can think about negative powers. So if we take the next step, we know that 1 divided by 10 is going to give me 1/10 or 0.1. And if I reduce the power, I can see I get 10 to the power of -1. Now I can continue doing that, divide by 10 again, which gives me 1/100 or 0.01. Then I reduce the power, I can see that I have 10 to the power of -2. Now is a good point to ask, what do you notice about 10 to the power of 2 and 10 to the power of -2? So it's a really good point for discussion. I can continue then even further with 10 to the -3, divide by 10, and I get 1/1000 or 0.001. Now, we can ask more of them key questions. What's the difference between positive and negative powers? Why is 10 to the power of 0 not equal to 0? So again, to help them understand this and really anchor their knowledge, I'm going to use a place value grid. So I can see that I've got 1 in the tens and 1 in the ones, and I can link that to 10 to the power of 1 and 10 to the power of 0. But what happens if we go beyond that decimal point to the right? Well, I've got 0.1, which is tenths, which is 10 to the power of negative 1. 0.01, which is in the hundredths, so I have 10 to the power of negative 2. And then 0.001 in the thousands, which is 10 to the power of negative 3. So it's really nice to link that learning. Keeping that place value grid in mind, I'm now going to look at it more abstractly. So we can see that 10 to the power of negative 1 is equal to 0.1, which is equal to 1 over 10, which is the same as 1 over 10 to the power of 1. That also works for 10 to the power of negative 2, which is equal to 0.01, which is equal to 1 over 10 squared. And 10 to the power of negative 3, which is equal to 1 over 10 to the power of 3. Now, there are two really key learning points here. One is that the students need to be comfortable seeing the indice version, the decimal version, and the fractional version all alongside each other and understanding that they mean the same thing. The second thing is that they notice the link between 10 to the power of negative 1 and 1 over 10 to the power of positive 1. We can see that that works for everything, and we can see that there with 10 to the power of negative 2 is the same as 1 over 10 to the power of positive 2. So how could we take this further? Well, we could look at a question like this, which is really nice, I think. How else can we write 0.4? We could start with 4 multiplied by 0.1. We could do 4 divided by 10, 4 multiplied by 1 over 10, 4 multiplied by 10 to the power of negative 1. We could also think of it like this, 40 multiplied by 0.01, 40 divided by 100, 40 multiplied by 1 over 100, 40 multiplied by 1 over 10 squared, and 40 multiplied by 10 to the power of negative 2. Now, a really lovely question to ask at this point would be, what's the same and what's different about these two numbers? Are they both equal to 0.4? Okay, if we want to take it further, we can look into that. So we have 0.4 is equal to 40 multiplied by 10 to the negative 2. Now let's split up that 40. We know that that's 4 multiplied by 10. So we can write 0.4 is 4 multiplied by 10 multiplied by 10 to the negative 2. Now, using our rules of indices, we can put them together and we have 0.4 is 4 times 10 to the negative 1. So yes, they were the same. Right, we can take it even further with our premium resources. So these are all on our website, and this is a really lovely question. So it's the sort of question where it's not in standard form and the students are expected to correct it. So just pause the video and have a little think, read through the question. How would you teach this currently? Okay, I would make a start by concentrating on just some of the questions and thinking about the understanding that goes into that part of the question. I'd sort of question the students with things like, what's the same, what's different? I want them to spot that they're all to the power of negative 4. And then we'll start thinking about the numbers at the front. How can we write 70 in standard form? How can we write 0.07 in standard form? And then we can link the powers to the indice rules. How do we write 10 to the power of 1 multiplied by 10 to the negative 4 as a single power of 10, which links nicely to the question there in the bubble. So that's brought us to the end of the bite-sized snack. I'd just like to make some summary points. One of my key points is to use links to the previous knowledge of indices. They would have just done this, so this should be quite fresh in their minds. Return to place value grids to support the understanding and really anchor that learning. The use of pattern spotting to understand the structure. Making connections between the indices, the fractions and the decimals. And as teachers, we need to make that explicit. And then explore non-examples of standard form. So where numbers are not in standard form to really get to grips with the misconceptions. Okay, so finally, thank you for joining me. I hope you'll be joining us for more secondary snacks.